Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the calculations of du and dh for ideal gases. The values of u, h, and s cannot be measured directly, and they are calculated from measurable properties using the relations between thermodynamic properties. However, those relations, given the changes in properties, lower the values of properties and specified states. The differential changes in the internal energy and the enthalpy of an ideal gas can be expressed as the change in internal energy or enthalpy for an ideal gas during a process from state 1 to state 2 is determined by integrating these equations. To carry out these integrations, we need to have relations for Cv0 and Cp0 as functions of temperature. 4 ways to get the answers to the above differences. 1. Integrations to be carried out with the fixed specific heats. 2. Integrations to be carried out with the real specific heats. 3. Integrations to be carried out with the average specific heats. And 4. Make the difference from the tables. The topic of this subtask is about the calculations of du and dh for ideal gases with the fixed specific heats. When the temperature ranges is not too large and the calculation accuracy is not required highly accurately, the fixed specific heats can be used. The specific heats can be determined as 1. The experimental values at 25 degrees centigrade. Commonly used gases can be found in the appendix. 2. The fixed values for the molar specific heats are obtained from the molecular kinetic theory. The fixed values for the molar specific heats from the molecular kinetic theory are shown in Table 4.1. For the calculations of du and dh for ideal gases with the real specific heats, the specific heats are not fixed values. Instead, they are functions of temperature. In this method, the integrations are carried out with the real specific heats. That is, the specific heats are expressed in the polynomial equations of temperature with experimental values. The factors of the polynomial equations can be found in Appendix A7 for some gases. This is an accurate way to calculate the changes of u and h. For the calculations of du and dh for ideal gases with the average specific heats, the specific heats are averaged as a fixed value in a temperature range. The average specific heats can be found in Appendix A7 for some gases. The last way for the determination of du and dh is based on tables. The integrations are straightforward, but rather time-consuming and thus impractical. To avoid these nebulous calculations, U and H data for a number of gases have been tabulated over small temperature intervals. These tables are obtained by choosing an arbitrary reference point and performing the integrations by treating state 1 as the reference state. In the ideal gas tables given in the appendix, 0 Kelvin is chosen as the reference state, and both the enthalpy and the internal energy are assigned 0 values at that state. The changes of U and H can be easily found with tables. The choice of the reference state has no effect on delta U or delta H calculations. The U and H data are given in kilojoule per kilogram for air and usually in kilojoule per kilomole for other gases. The unit kilojoule per kilomole is very convenient in the thermodynamic analysis of chemical reactions. Therefore, we need to choose a convenient reference state and assign a value of 0 for a convenient property or properties at that state. For water, the state of saturated liquid at 0.01 degrees centigrade is taken as the reference state, and the internal energy and the entropy are assigned 0 values at that state. For refrigerant 134A, the state of saturated liquid at -40 degrees centigrade is taken as the reference state, and the enthalpy and the entropy are assigned 0 values at that state. Note that some properties may have negative values as a result of the reference state chosen. It should be mentioned that sometimes different tables list different values for some properties at the same state as a result of using a different reference state. However, in thermodynamics, the changes in properties are concerned with, and the reference state chosen is of low consequence in calculations as long as we use values from a single consistent set of tables or charts. Okay, that's all for this task. Thank you very much, and see you next time.